Hi, it's Scott with Mr. Robot Electronics. Well, a lot has happened since I showed you an Arduino Uno-based replacement for the dead Mostek MK5017 clock chip in this Heathkit digital clock. And it's live now. It'll even wake you up in the morning. Or let you snooze. I've created an ATmega based board that perfectly emulates the original chip, and it's now on sale in my Tindy and eBay stores. It was a long road getting here. I'll walk you through the hardware design and a bit about the software since I'm a hardware guy at heart. By the way, this is an open source project, so all of the schematics, Gerber files, parts list, and code are available on the Coburg GitHub site. I started with an Arduino Uno, which has an ATmega 328P processor. For cost reasons, I planned to use an ATmega 8 in the small 32 TQFP package. I used the CD40-109 level shifters to translate between the 15 volts on the clock and the 5 volt ATmega signals. A small 5 volt low dropout LDO regulator provides the 5 volts power. Timekeeping is accomplished with the 50 or 60 Hz line frequency, and an internal 8 MHz oscillator provides system timing. I used a breadboard to transition between the chip on the Uno board and the ATmega 8 chip in a DIP package to prove things out before making a board. This went well until I got to the part where I had to add the alarm function. First of all, interpreting the MK5017 datasheet to understand exactly what the alarm tone should sound like took quite a while. Fortunately, there were YouTube videos with the alarm sound, so I had something to compare to. But I soon found out that the PWM tone library that I needed to generate the alarm tones that worked on the Uno board did not work on the ATmega 8. Oh. So I switched back to the ATmega 328 that was on the Uno board, specifically the newer PB variant, which has 4 more I/O pins that I needed. Many of the newer Uno boards use the PB variant, and I hear rumors that the original P version will be discontinued at some point. I got the first set of boards built at JLC PCB. I highly recommend them. Assembly was going to be many times what the boards cost, so I chose to hand assemble them with parts from DigiKey. I only buy parts from them. I'm getting pretty good at soldering these tiny 0402 capacitors. I had to keep things small to fit everything on the board. The next version will use 0805 components, which are much easier to hand solder. I test the finished boards in a zero insertion force ZIF socket in my clock. Like I say, I'm not a software guy, but I was able to write 1,200 lines of code that works. It's not pretty, but it works. And if there's any updates, I'll be sure to upload those to the repository. The MK5017 came in 3 variants, AA, BB, and AN. The AA version is just the basic clock and alarm function. The BB version is a clock calendar combination, but I haven't written that code yet. If there's demand, I will provide it. But I think the majority of clocks out there are just the basic AA version. The AN version is a clock radio that comes in a 28-pin DIP instead of the 24-pin AA and BB versions. I'll only be selling an AN version if there's demand, as it's a lot of extra board design, fab, and coding. I only made one error on the board design, and that was routing the programming connector to the wrong pins on the processor. I ran them to the UART pins instead of the SPI pins. So that means I have to solder wires onto the tiny SPI pins to program them, instead of using pogo pins on the bottom of the board as I had intended. And due to my lack of a sensible floor planning, the boards ended up being a lot more expensive than I had hoped because I had to use super tiny vias. I was trying to keep all segment and digit outputs on the same port of the ATmega, which is really not necessary. I have a new board design that doesn't need tiny vias, so it's much cheaper and just needs some pinout and code changes, and the programming connector wiring will be fixed as well. The other thing that delayed me for weeks was a random resetting problem. I finally got this ironed out by disabling the brownout detection in the Arduino IDE. The power supply in the Heathkit clocks is not regulated, and apparently line voltage noise was causing tiny spikes in the supply voltage that led to a reset. In case you're wondering why I didn't just program the chips with the UART interface, it's because the chips are only manufactured without a bootloader installed. You need the SPI interface to load the bootloader. Speaking of reputable distributors, I use DigiKey exclusively. They only charge $8 Canadian for duty-free overnight FedEx shipping, which is fantastic. Mouser is the other reputable distributor I recommend, but the shipping and import fees means I only use them if DigiKey doesn't stock something. I realize that most people are not proficient at tiny SMD soldering, so right now I'm only selling fully assembled and tested boards. As this is an open source project, all of the hardware and software files are now available on Codeberg, which is a new GitHub alternative that is not ruined by Microsoft. Links are in the description. I use EasyEDA design software. It's free, and you can copy the design files into your EasyEDA working directory if you want to modify things like the schematic or the layout. Gerber files are also available. As always, I provide full technical support to get you up and running. The boards are up for sale on Tindy and eBay. Links are in the description, and I provide a 1-year warranty also. Thanks for watching.